Good morning. Our topic for discussion is on elastomers. So, coming to the classification of impression materials are basically classified into two types, that is, rigid and elastics. So, the rigid materials, as we all know, are the impression plaster, impression compound, and the zinc oxide eugenol paste. So, now if we come on to the elastics are classified into two types. They are the elastomers and the hydrocolloids. Hydrocolloids, again, we know there are two types, reversible and irreversible. The reversible example is an agar, and for irreversible it is alginate. And the second portion of elastics is the elastomers or the synthetic elastomers. So they are basically divided into three, that is the polysulfide, polyether, and silicons. The silicons again are further divided into two. They are the addition silicon and the condensation silicon. So elastomers are referred to a group of rubbery polymers which are either chemically or physically cross-linked. They can be easily stretched and can recover the original dimension when applied stress is released. Most of the elastomers are two component systems in which the setting occurs through either the chain lengthening polymerization or the chemical cross linking. So, coming to the elastomers, they are classified into four as we earlier discussed: the polyether, the polysulfide, condensation silicon, and the addition silicon. So, according to the viscosity, they are classified as light body, medium or regular bodied, and heavy body or and a putty consistency. So, going in detail about the first one, polysulfides. Polysulfide it was the first rubber impression material. The main component is a multifunctional mercaptan SH or a polysulfide polymer. It is classified as light, regular, or heavy bodied depending upon their viscosity, and they flow under the load that we give for impression making. So the properties, if we check closely, it has a working time. The polysulfides have a working time of about 4 to 6 minutes, setting time of about 12 to 16 minutes. They have a permanent deformation 2 to 3% when held under 12% compression for 30 seconds, and it has a shrinkage of about 0.3 to 0.4%. So it should be poured immediately. It is hydrophobic in nature. It has excellent reproduction of details. It is highly compatible with the gypsum products, can be electroplated, and has an excellent shelf life and high tear strength. So if we talk about the advantages of polysulfide, it has a high tear strength. It is available in different viscosities. It has a long working time and a long shelf life. So everything comes with disadvantages. The disadvantage would be it is hydrophobic, it is messy and it can also stain clothes. It has an offensive odor, so cannot be used in the patient's mouth, as is the reason as to why it is discontinued, and stretching can lead to distortion. Moving on to the next material, it is polyether. It was introduced in Germany in the late 1960s. It has a good mechanical and dimension stability. It has a short working time and it is very stiff and expensive. It is again classified or has different consistencies. It is a light, regular, or heavy body depending upon the viscosity and flow under the load. So coming about the properties, it has a mixing time of about 30 seconds, setting time of about 8 minutes. It has a pleasant odor and taste. It has adequate tear resistance and elastic properties. It is hydrophilic in nature. It becomes a set. Once it is a set material, it is extremely stiff and it cannot be electroplated. Its advantages are: it has a short working and setting time. It is accurate. It has an adequate tear strength. It is hydrophilic. It has a long shelf life, and it has a good dimension stability. The disadvantages of polyether are its stiffness requires blocking of the undercuts, and it is expensive, and multiple casts cannot be poured due to the stiffness of the material. Now moving on to the third material, it is the condensation silicon. So it is present as two component systems, base and catalyst paste. So the properties of that are: it has a working time of roughly about 45 seconds, setting time of 6 to 8 minutes. Its tear strength is better than polysulfide. Its tear strength is weaker than polysulfides. It is hydrophobic. It has a permanent deformation due to shrinkage. It is high due to evaporation of ethyl alcohol and it can be electroplated. So the advantage is it has a short working and setting time, and the custom tray is not required. it is clean and pleasant to use. The disadvantage is it has high polymerization shrinkage. It has a volatile byproduct. It has less tear strength and hydrophobic. Since this condensation silicon has a condensation reaction, it also the final result comes with a byproduct. That is why it has high polymerization shrinkage. Now coming on to the fourth type, it is the additional silicon, which is the most desired type in the present practice. It is frequently called polyvinyl siloxanes or vinyl polysiloxane impression material. Addition reaction polymerization is the chemical reaction and is terminated with vinyl groups and is cross-linked and actuated by a platinum catalyst. So the properties of the most desired material is it has a mixing time of roughly about 45 seconds, setting time of 5 to 9 minutes. It has a pleasant odor and color. It has excellent reproduction of the surface details. It has excellent dimensional stability. It has a good shelf life, good tear strength, and it is hydrophobic. Earlier it was hydrophilic, so then surfactants were added to make it hydrophobic. The advantages are it is easy to use, it has a quick setting, it has a good shelf life, it is dimensionally stable, and has excellent surface detail reproduction. The disadvantage is it is hydrophobic, low tear strength, and expensive. Since it is hydrophobic, though hydrophobic is a disadvantage, since it is hydrophobic, even when there is saliva or blood pooling in the region where the impression is desired to be taken, since it is hydrophobic, the impression will slightly push away the water content and record the detail. Now, manipulation of these materials, there are a few techniques. The three techniques are the multiple mix technique, the single viscosity technique, and the putty wash technique. So if we want to go into detail about each technique, the first technique is called the multi-mix technique or the single stage technique. Here, as we can see, an impression tray is selected in the patient's by placing it in the patient's mouth. A tray adhesive is applied over the tray and is air dried to remove the volatile content. Then light body is material or the syringe material is applied around the prepared tooth. The heavy body or the putty material is placed in the tray. So the tray material is the heavy consistency of the putty material, and the light body or the thin consistency material is placed on the surface of the tooth. Then and light body is also applied on the surface of the hard material on the putty, and it is then placed in the patient's mouth. Once it is set, it is removed. This is the technique. Now there is another technique called a single viscosity technique or the monophase technique. In this technique, only one mix is made. Part of it is placed in the tray and another part is placed in a syringe for injection. So the medium viscosity of the additional silicon and polyether can be used for the same. So in this picture, the single consistency, there is a monophase impression material can be used. The same kit material can be used as a tray material as well as the syringe material. So the syringe material, the tray material will be quite strong enough to be used as a or similar to that of a heavy bodied consistency, and the syringe material, because of the property called shear thinning, it when excess pressure is applied from the syringe, it will result in the flow of the material, and therefore it can act as the light body material. Now the other technique is the putty wash technique. It is a two-step technique. In this technique, what happens is the equal amounts of the putty material, the base and the catalyst are taken. Also to be understood is instead of a latex gloves, a vinyl gloves is used, since the sulfur contents in the latex can contaminate and prevent or inhibit the setting reaction. So a vinyl gloves is used, and equal portions of the base and the catalyst is taken on the putty, and then they are mixed by a procedure called kneading. Then once this is done, this putty material is placed on the tray, and a separating sheet or a cellophane sheet can be used, or a separator can be used, and is placed in the patient's mouth, and an impression is made. So separator or a cellophane sheet is used to create space for the light body material. So once this putty material sets, it is taken out and the cellophane sheet is just peeled off, and then equal amount of the base and catalyst paste of the light body is dispensed. It is mixed on a glass slab with a spatula, or also pre-mixed or tips are available to pre-mix the material directly from the cartridge. So then the light body is applied onto the areas where the cellophane sheet was there, and then it is placed in the patient's mouth. So since it has a good flow, it sets. Just to recap, if you could see this picture, the equal amounts of putty is taken out and they are needed, placed on the tray and placed in the patient's mouth. Once that is done, then the cellophane sheet is just slightly removed and the light body is placed in the tray as well as in the position where the tooth is being prepared, and then placed in the patient's mouth and an impression is taken. So these are the different techniques. Thank you.